Welcome, everyone, to another episode of Block Talk. My name is Brenda, and I'm a PM on the Azure blockchain team.
And I'm Kale. I'm on the blockchain team as an engineer. And today we're going to talk a little bit about IPFS, specifically for enterprise and consortiums.
So, Kale, what exactly is IPFS? We hear about this term a lot.
So IPFS technically stands for Interplanetary File System. And what that means is basically it's a peer-to-peer network that functions similar to the way a blockchain functions. So when we think about how blockchains function with the immutability aspect and these peer-to-peer networks for replication of data, IPFS borrows a lot of concepts from that, but it's very focused on the storage aspect. So you can think of this as kind of a decentralized storage mechanism that we can use. Now, traditionally, and what you can see on the screen here, we'll call this core IPFS. This is the main protocol that IPFS as a group is creating. There's a group called Protocol Labs who's actually building a lot of this tech. It's open source as well. And basically they built a lot of this technology to build this public side. So essentially on the internet, as it functions today, if we're standing up a website, we traditionally have to go to some cloud vendor or someone else who's going to host this thing for us. And then essentially we'll get a URL back. Now that URL is kind of like a location, right? So where we can go get the content.
Yeah.
With IPFS, we can kind of bypass that. So we're more of a content-based system.
Interesting. So one question for you is, if I'm storing some things on this IPFS system, how do I make sure that, I'm not quite sure where it's stored? How do I make sure that it's secure and, not just any random person can go see all my stuff?
Yeah, so there's a couple things with that. One is the IPFS network in public form that you see here is a bunch of nodes. So anybody in the whole world, just like the internet, you can stand up a server and put it on the internet. Same thing here. You can stand up a node that's part of the IPFS network. Now, as I mentioned before, it's content-based. So when we put content into there, so let's just make it simple. It's going to be a file, a PDF file.
Okay.
So if we take that PDF file and give it to one of our nodes and say, please store this for me, you will get back a content hash. Now, the interesting thing is it's also immutable. So that content hash is linked directly with that content. Those two can never change. So in the future, if you have an updated PDF, you're going to have to put a new PDF up there, and you'll get a different content hash back. And this is the thing that you would store and then share with people in order to access the data. So in terms of privacy, though, in the public space, I won't say there's no privacy. There's a very strong kind of governance around how that content is maintained so that it's immutable. But there isn't a strong governance around, can I see Brenda's data? If I know where the content hash is, I can go get it.
Got it. Okay.
Now, where this kind of blends into the enterprise, and I switched to the IPFS on Azure slide. So the group over there that builds libp2p, which is kind of the back end for IPFS, have put some provisions in there to allow us to run private or permissioned versions of these networks. So in this case, now you're getting closer to what you were talking about, Brenda, of, hey, I'm a company, we have a blockchain, and we have some applications we built around it. We need to store some big data. When I say big data, I mean like blobs of data.
Right.
And so when they say we need to store this today, what you would have to do traditionally is say, well, we need to build a system to store that data off-chain. Then we need to build a hash for it so that we can guarantee that it hasn't been changed.
Right.
And then we need to share that hash with somebody.
Right.
This automates that.
Got it. And then so in that case, is this basically solving the problem where, in many scenarios you might have to combine documents with your smart contracts, but then if each individual member is hosting their own files or blobs, how does someone else on the system actually go view that data? Let's say, hey, I uploaded a PDF file with supporting information for this particular smart contract. And as member 2, I might want to go access that. But if member 1 is storing it, how do I actually see that information?
No, it's a great question. So the idea around this private side is, again, we have a permission network. So only nodes that can be on this network are ones that we've authorized to be on this network. Now, what you see on the screen here are 2 consortium members. You can think of these as like 2 businesses, business A, business B. So if we look at the left side, we'll call him business A. He's using one of these ledger technologies, and he says, okay, I need to attach this PDF, which has some legal terms or something around this content that I'm storing in the blockchain. And so they get back a hash when they store it in their IPFS node. And essentially we put that in, let's say it's Ethereum, we put it in a smart contract. So now that content hash is state in the contract. Now, basically, the DAP that's showing this information back to people is exposed to this other consortium member. Let's say that's you or your business B.
Okay.
For you, it's very seamless because basically you're just going to say, oh, cool, there's a document attached to this. Let me see it. When you click on it, behind the scenes, your consortium nodes, your Ethereum nodes, are basically going to talk to your IPFS nodes.
Okay.
Now, you're connected to me through a VPN tunnel. So essentially what happens is your node will say, I know that content hash, but I don't have it. But Kale's group does, Business A does. Let me ask him. So he gets it from my network and says, okay, let's replicate it to Brenda's.
Got it.
Now what's great is if Brenda's a big company and has a bunch of people accessing this data, it's now cached on her system.
Great.
So it doesn't have to traverse. So in that way,
really cool.
it kind of functions like a CDN. So
Yeah.
it's doing replication. Yeah.
That is pretty neat. And so is this solution that we have, IPFS on Azure, is it specific for a particular blockchain, like, for example, Ethereum, or is it specific for Corda, or do we have different integrations there?
No, that's the nice thing about it. So essentially, there's many ways you can talk to IPFS. They have a CLI client. They have a REST API. So traditionally, that's been kind of the approach that people have taken. They said, okay, I have my ledger technology with a DAP, and now I'm going to use this REST endpoint as my storage network.
Oh, okay. Neat.
So
So it basically works with whatever blockchain that you want.
That's right. It's very agnostic because it's just an endpoint that we're hitting to get this data.
Nice.
Now pop over to the Azure portal here for a second, and if you're in the Azure portal and you want to start taking advantage of this, and when you're watching this video at the bottom, there'll be some links over to some of these pointers for you, so don't feel you need to watch what URLs I'm going to here because you can get that later. But if you just type IPFS, I just hit create new resource IPFS, and then if you hit the IPFS, now you'll notice it's in beta. That doesn't mean that it's broken or anything like that. Because this technology for doing the permission networks is so new, it's basically what's called an experimental flag in IPFS. And so we have this flag that's basically at the protocol level saying, don't ever let this talk to public networks. Because that would be a disaster if we had a consortium and then we started sharing data. So basically, don't be afraid of the beta symbol. But basically, when you click through here, there's links to documentation. And you can basically fill out a 4-step procedure here, which essentially asks you just things. What do you want to name your nodes? How many nodes do you want? You can put in your credentials so you can manage your nodes if you want to pop onto them and look at them. And that's pretty much what you're going to get back. Now, in the interest of time, I already have one spun up over here. And this is what basically gets output from this. So what we're doing is basically creating the infrastructure to make that node management easy. In this case, I spun up 2 nodes on my network. And you can see that we have load balancers in here, so we don't have to know what IP addresses we need to hit for these specific nodes. And we have the high availability with the availability sets, managed disk, and others.
One quick question, Kale. So here you have 2 nodes in your single Azure subscription. Is it possible to connect from, let's say, another Azure subscription to the same IPFS network?
That's right. So if we, and I'll show you that here in the interface, if you were to step through this, you'll see. Just fill out where you want to put everything. You'll give it a resource group. And on the second tab under network, you'll see this is where we put in how many nodes we want. You can do up to 10 right now. Now keep in mind, it's 10 on my subscription. So if Brenda's another enterprise is going to work with me, she could have her own Azure subscription, or she might not even be using Azure at all. So this thing works across cloud too.
Oh, great.
We've automated a lot of it, so if they're using Azure, it's a great experience and very easy to kind of onboard. But if they want to use an on-prem nodes or they want to use some other cloud, they can certainly attach from there. So we got 10 nodes we can provision here. We can set the size of them. So we're getting storage there because basically we're going to be persisting this data. But here's where we would say, hey, in my network, I'm creating a new one. So if I'm the guy who's initiating this, I'll create a new network. If I'm joining an existing one, you'll notice you get prompted for some different things, like a member ID, a swarm key, and a boot node address. So in our case, Brenda's Enterprise B, she would be asking me, obviously, hey, I want to join your permission network, and I would share this information with her.
Got it. And then so I can just fill it in, and then I would basically be joined to your private IPFS network.
The only other piece we have to do is the VPN. So by default, if I said, hey, I need to spin up a small cluster so I can just test stuff locally, I would leave this all at defaults. If I wanted to do the scenario where we're going to attach to different participants, then I would also turn a toggle this to yes. And this allows that VPN gateway, the network, to be stood up.
Nice.
So that we can do that.
Cool. Thanks for explaining.
Yep. So basically, we get all this stuff provisioned. I wanted to show you really quickly what it looks like after we have it running, and I'm going to show you some terminal windows here. But the reality is this would be exposed in your DApp, your application. But in the interest of the demo here, we'll just show what it looks like here. So basically, I'm on node 1. I have 2 nodes, remember. And if I hit this API, you'll see I'm hitting this Swarm API and asking it for peers. And you'll see that there's 1 peer that I have. So basically, this is showing that I have another person connected to my network. So as Brenda would bring her nodes in, let's say she brings 2 or 3 nodes in, I would see those peers appear here as well. This goes to the permissioning thing because she has the Swarm key, she has access to my network, so she can be on. Now basically, what I'm going to show here is essentially just uploading a file. And so to do that, we're just going to hit a different API. So we'll just do an add here. Now I'll just upload a file. And I'm just using curl here just to show how this works. So you can see what we got back here is, as soon as I uploaded this, I got back the name of this file that I created, the hash. This is that content hash I was talking about, and how big it was. Now, if I wanted to go view that, and again, I'm on the same node, so this is not traversing any network or anything. We're just saying, hey, go find this piece of content that exists out there now. So I would do this cat, and there's a bunch of other commands you can do. I'm just showing this one. You basically take that content hash, and you can see testing from node 1. This is the file that I uploaded. Now, if I pop onto node 2, five, and you can notice my peer up here was 5, so that's my neighbor that I want to talk to. So I'm just going to log into him. And once I'm logged into him, I'm going to do the same thing again. So this time I'm not going to upload anything, I'm just going to view it. And you can see testing from node 1. So I'm on node 2 right now, reading node 1's content. What happened was exactly what we were talking about when we were in the slides over there. It didn't have the content. It immediately went to node 1 and said, hey, you have this content, please give it to me. He gave it to him, now it's on node 2. So now they both have a copy of it. If someone tried to be nefarious and tried to change the data, let's say, or something, it's not possible, right? Because we have no way to basically modify the data that's up there. We would have to create a new version of this document, upload it, get the new hash, and then put that in our persistent blockchain thing, like a smart contract or something.
Right.
So that's just kind of a little walkthrough about what we're talking about with IPFS on Azure. And hopefully it gives you a little taste for what's happening there. I know there's a little terminal window there, but basically your application would be surfacing that through that REST API.
Got it. Cool. Well, thanks so much for talking to us about IPFS today. And thank you guys all for watching. As Kale mentioned, if you want to access the links from this talk, you can see them in the description below. And if you want to follow more updates coming up with blockchain at Microsoft, you can follow us at MSFT Blockchain on Twitter. Thanks, everyone, for joining today.
Thanks, guys.